Hello and welcome back everyone. We're going to take a look at this question from the A and AS level chemistry paper. Question 11. In alkaline solution, MnO4 minus ions oxidize SO3 2 minus to SO4 2 minus. The MnO4 minus ions are reduced to MnO2. What is the ratio of the two ions in the balanced chemical equation for this reaction? Now we are going to follow a process here that's going to help us to balance these half reactions in an alkaline solution. There's a few steps that we need to follow. Let's go through them. So first, let's start with the MnO4. So the MnO4 became MnO2. So step one would be balance the magnesiums or manganese and balance the oxygens. The manganese or the Mns are balanced. Now we need to balance the oxygens. So on the left hand side I have 4, on the right hand side I have 2. So to balance the oxygens I need to add water. So on the right hand side I can add 2 molecules of water. Now by adding the 2 molecules of water, I've also added 4 hydrogens. Now the right hand side has the 4 hydrogens, and so I need to add the 4 hydrogens on the left hand side. Now when we are adding hydrogens to balance, we add it as H+. Now I know the question said that we are balancing in an alkaline solution, but we will take care of the H+ at the end. So we've balanced the oxygens by adding water, we've balanced the hydrogens by adding H+, and now all we need to do is balance the electrons. So to balance the electrons, there are a few ways. I'm going to balance the whole left hand side and then balance the whole right hand side. So on the left hand side, I have H+ and I have 4 of them. So one of them has a +1 charge, so 4 of them will have a +4 charge. The MnO4 has a -1 charge, and so this whole left hand side is going to have a +4 -1, which is a +3 charge. Now the right hand side, MnO2 has no charge, H2O has no charge, and so the whole right hand side has a 0 charge. So to balance, I need to add 3 electrons to the left hand side to make the left hand side 0. So I'll add my 3 electrons like so. And now this reaction or this half reaction is complete. Let's move to the next one. So the next one says SO3 2 minus becomes SO4 2 minus. Just like we did before, look for the sulfurs. The sulfurs are balanced. Now let's look to balance the water, or the oxygen rather. On the left hand side, I have 3 oxygens. On the right, I have 4. So I need to add 1 water molecule to my left hand side. So 1 water molecule like so. But again, by adding that water molecule, we've added in hydrogens. And so to balance the hydrogens, we need to add H+. So on the left, we have 2 hydrogens, so I need to add 2 H+ on my right. Next, look to balance the electrons. On my left hand side, I have a total charge of -2 because water is 0 and the SO3 has a charge of -2. On the right hand side, I have a charge of -2 from the SO4 and then a +2 from the H+, and that's 0. So my left hand side is negative, my right hand side is 0. I can make the right hand side negative by adding 2 electrons to my right hand side. In doing this, my right hand side now has a charge of -2. Now what we need to do before we join these reactions together is we need to balance the number of electrons. For the first reaction, we have 3 electrons, and for the second reaction, we have 2 electrons. So to get the lowest common multiple, we multiply by each other. So the lowest common multiple will be 6. So for the top reaction, we'll multiply everything by 2. Let's do that. So this becomes 6, this becomes 8, that becomes 2, that becomes 2, and this becomes 4. Now for the bottom, we're multiplying by 3. So this is going to be 3, that's going to be 3, that's going to be 3, this is going to be 6, and that's going to be 6. Now that the electrons are balanced, we can join the reactions together. Now before we do that, it'll be advisable to cancel things that are the same. For example, on my right hand side, I have 6 electrons, and the 6 electrons here will cancel. Then look for the hydrogens. Here I have 6 hydrogens, and here I have 8, so I'll be left with 2 hydrogens. I'm just going to highlight these so I know that we need to bring them down. The MnO4s won't cancel, the MnO2 won't cancel, the water might cancel. On this side I have 3 waters, on that side I have 4. So I can cancel 3 from here and 3 from the right, leaving just 1. There's nothing else to cancel, so let's bring everything else down. So I have 2H plus MnO4 minus plus 3 SO3 2 minus, producing 2 MnO2 plus H2O plus 3 SO4 2 minus. Now at this point, we can give our answer. They want to know what is the ratio to Mn of MnO4 to SO3 2 minus. It's 2 to 3. So the answer here is A. But we're not done. We can complete this. Since we are balancing in an alkaline solution, we must remember that we can't have H pluses lying around, because in an alkaline solution, you have an excess of OH minus. And so to balance the to balance the H pluses, we will add OH minus in. So to this side, we're going to add 2 OH minuses, and to this side, we're going to add 2 OH minuses. So this OH minus and that OH minus and that H plus will form water. And so we're going to have 2 MnO4 minus plus 3 SO3 2 minus plus 2 molecules of water produces 2 MnO2 plus H2O plus 3 SO4 2 minus plus 2 OH minus. Now there's a water here that can cancel with 1 water from here. And so my final answer then is going to be 2 MnO4 plus 3 SO3 2 minus plus H2O gives you 2 MnO2 plus 3 SO4 2 minus plus 2 OH minus. And that's how you balance a reaction in an alkaline medium.